Hello. So today we will be solving the question of latest Codeforces contest. It is of Codeforces round 930, Division 2, A problem, that is shuffle party. So let's first understand the question. So you have been given an array A1, A2 up to AN in which AI is equal to I. Now there is an operation which is named as swap of K, which is defined for K is greater than or equal to 2. You will take the largest divisor of k, which is not equal to k itself, then swap the elements which are at position d and k. Okay. So first let's understand the question, what it is telling. Okay. So you have been given in input as only n. Now what the thing is that your array looks like, if let's n equal to 4, so you have been provided like 1 2 3 4, ai is equal to I, ai is equals to I, means a1 is equal to 1, ai is equal to I, a1 a2 is equal to, this is the starting point. Next thing that we have to do the operations, means there are total, if you could say that you have to perform for operation of up to n, means if n is equal to 4, if n is equal to 4, so you have to perform the operation swap 2 swap 3 swap 4, swap 2 swap 3 swap 4. Let's say your n is equal to 5, so your operation will be like swap 2 swap 3 swap 4 swap 5. Okay. Next thing that we have to understand is that how does operation do? Well, what are the operation doing? Let's understand. Okay, so let's see first this operation, this first operation, this swap 2. Swap 2 tells to swap a2 and a1. What it means that a2 means at second position and this is first position. Swap this and this. Okay, swap this and this. So we have swapped it, and the one is separate too. So the question is telling that what will be the final position of one that we have to give. In other words, see, this is the question: find the position of one in the resulting array. What should be its position? In other words, find such j that aj is equal to 1 after performing this operations. Okay, so let's understand this test case, which is n equal to 4. Okay, so swap 2 swap a2 and a1, which is here was swapped. Now this was swapped 2 and 1 here. Now at the third operation swap 3, we have to swap actually this 3 a3 and a1. Okay, a3 and I, here is operation happens. Okay, this is the resulting array. Okay, so swap 3 a3 and a1, so 3 and 2, so swap, so this was the resulting array 3 1 2 4, and then swap 4 happened, which was a4 and a2. Why a4 and a2? Because swap 4 takes a4 and that a4 sees what is the largest divisor of 4, that is 2, obviously 2. So we will be swapping with a2. Okay, we will be swapping with a2, which is largest divisor of a4. Okay, so that's why swap a4 and a2, and so we get the resulting array. So the swap operation happens in a2 and a4, so our 1 goes here at the 4th position and our answer is 4. Okay, let's understand with another example. Okay, so you can get better clarity. Let's your n is equal to 8 and this is your array ai is equal to I. At the first operation, as I tell to your a1 and a2 is swapped. Here, as you know, a3 and a1 is swapped here, 2 and 3. Here as a4, here as a4, and okay, a2 and a4 is swapped, which is 4 and 1. Now let's understand what is swap 5. From here, we will understand swap 5 operation. Swap 5 happens here and here. Obviously, we can see here. So it gets shifted. Then swap 6. Swap 6 tells replace 6 with 3, a3. Replace 6 with a3. This is 6th position. This is 3rd position. It gets swapped. Then a7, and what is it? What is its largest divisor? That is 1. So we swap 5 and 7. Now what is the then comes 8, swap 8. So what is the largest divisor of 8? That is 4. So we swap 8 and 1. So this is our final array. Now here, are you able to get something? That 1 is coming at position 1, 2, 4, 8, and next let's our n is equal to 16. So see, understand, if I have operation of swap 9 will go with 3, Okay, fine. Then 10 will go with 5 because okay, so sorry, it's not 3 position. 9 will go with a9, a3, a3 is 6. Fine. Then 10 will go for a5, which is about 3, this wala. Okay. 11 will go with 1. 12 will go with 6 position, which is this. 13 is prime, so it will again swap here. 14 is 7, so here is 5. Okay. 15 will go for 5. This are, but the 1 is untouched. 1 is at 8 position, and when our 8 will be touched or happen, it is when it is 8 into 2, or when 16 comes. So when 16 will arrive, will do my greatest divisor is 8. My greatest divisor is 8, obviously. So I will swap. So from here, what do you are getting something? Yes, logarithmic. So 1 always is in at position 1, 2, 4, 2 cubes, up to so on. Okay. So how do we find, okay, what it will? So by law, let's your n is equal to 15. Let's your n is equal to 63. What does it means is that 64 is not arrived. Okay. So n cannot be at position 64. Sorry, 1. 1 cannot be at 64. Right? Because still it's not arrived. So where is 1 here? Where is 1 when there is n is equal to 63? It's less power than 64. That is that is 32. It is okay, that is 32. He means 1 is at 32. He will always remain in the power of 2. Okay, so how do we find this thing? Okay, n is equal to 63 by logarithmic. This log of 63, what it gives? It gives us 5. It gives 5. It gives 5. And on the basis of that, we raise to power its 2 raised to 5, and we get its position. Simple thing. Simple thing. So what our algorithm will be like? Okay, so whatever our n is, we will do its logarithmic of n, which will give its nearest power of 2. Nearest means at left side. Like if it's 31, so it will give 4, which is of 2 raised to 4 is 16. So as we need less power, like 31, so 1, where is 1? 1 is at 16. Like 32, so then it is at 32. So what we will do, we will do logarithmic of n, and let's say we take a x variable, which is our logarithmic of n. Okay, and what will be our answer? Our answer will be nothing but 2 raised to x. Thus we have to do this thing, and we will get our answer. We get a power from 31. The uh, nearest power, actually it is 6, but which is less than 31. Nearest power, and its raised to 2 should be less than 31. So it is 16. So by logarithmic applying, because this will give this when we find so what we have did is, you have been given an n, and you find it logarithmic power. So let's your n is equal to 31. So what is your x? X is your something 4 point something. Let's say it's 8. Let's say, just for the sake of it, it's something 4 point, which will eventually be x equal to 4. So that's why we are using this logarithmic function, and as x is our integer, so it will automatically turn into a step function type. Okay, so let's go to the code, and let's see how we will be solving it. So here we have taken input l, and then what we will be doing is int x, we just do logarithmic of n. So this will give our nearest raised to 2, which is less than like 31. So it will give 4. If it's 63, it will give 5. And what our answer is, our actually answer is our power of 2 raised to this x, and this is our answer actually. and it will be as n is our less than 10 is to 9, so it will be fine. And I would recommend that you use the power function of binary exponential. Okay, so I have to make it power function, which so binary exponential will work. Maybe power function I have not tried, but it's recommended that you use this power function of binary exponential. So here, if our b equal to 0, so you return 1. Okay, 1. And you just you let's say you x is equal to power of a comma b by 2. Yes. And okay, so if our b is even, so we do return x into x, else we return x into x into a. So this is just a binary exponentiation function. If you have not understood this function, you can see in online articles. There are lots of articles. So here just we are uh, doing recursive function, uh, which works in logarithmic of time. And if b is divisible, so we do x into x, and it's not, so it's in x into x into a. Okay. Thank you. If you have any doubts, you can ask in the comments section. Thank you.